In this lesson, we are going to learn about different types of fractions. When it comes to types of fractions, many textbooks describe categories such as like fractions, unlike fractions, proper fractions, improper fractions, and equivalent fractions. However, not all of these are strictly type of fractions. Let's dive deeper into this. Look at this fraction 1 upon 4. By looking at this one single fraction, can you tell me whether it is a like fraction or an unlike fraction? You simply cannot. It's impossible. Why? Because like and unlike are not inherent types of fractions. They describe the relationship between two or more given fractions. If I give you another fraction, let's say 2 upon 4, now we have something to compare. We look at their denominators, and since they are the same, we say these two fractions are like fractions. If the denominators were different, we'd call them unlike fractions. Now let's look at this single fraction again. Is it possible to figure out whether a single fraction is an equivalent fraction? Definitely not, because equivalence is not an inherent type of fraction, but rather a relationship between two or more fractions. If we are given with another fraction, let's say 2 upon 8, we can compare it with our first one, and if they have the same value, we call them equivalent fractions. On the other hand, if they do not share the same value, they are considered non-equivalent fractions. What we have learned here is that equivalent, like and unlike fractions represent relationships between two or more fractions rather than being independent types on their own. Now we are left with proper and improper fractions. These actually are specific types of fractions, and we are going to dive deep into them in this lesson. But before we do that, let's quickly refresh what we know about the relationships between fractions. Even though we have covered this in previous lessons, let's do a brief review right now. Take a look at this object. Let's divide it into 4 equal parts. On the left side, we have a fraction that represents 2 of those parts. On the right side, we have a fraction representing 3 of those parts. Do you notice a similarity between these two fractions? You can see that each block or each part in both fractions is exactly the same size. Because they are made of the same sized building blocks, we call these like fractions. Now let's look at their mathematical notations. The fraction on the left is 2 upon 4. The fraction on the right is 3 upon 4. As these two fractions have equal denominators, they are called like fractions. Now let's take another piece of the same object, but this time we are going to divide it into 3 equal parts instead of 4. Look closely at what we have now. On the left, we have a fraction from the object split into 4 parts. On the right, we have a fraction from the object split into 3 parts. Compare these two fractions. Does each block look the same in shape and size? Absolutely not. Because the original objects were divided differently, the individual pieces don't match up. This is why we call them unlike fractions. We will now look at their mathematical notations. The fraction on the left is 2 upon 4. The fraction on the right is 1 upon 3. Obviously, their denominators are not equal. Hence, they are unlike fractions. But why does it matter whether two fractions are like or unlike? Well, when two fractions are like, it is easy to do addition and subtraction operations. Simply add or subtract the numerators and leave the denominator exactly as it is. But same is not the case with unlike fractions. When we add unlike fractions, we simply cannot add the numerators together. Because the pieces are of different sizes, the process is a bit more complex, and we'll be diving into those steps in our later classes. So to recap, we have learned how like and unlike describe the relationship between fractions. An example of like fractions would be 1 upon 4 and 2 upon 4. Notice how they share that same denominator. Example of unlike fraction would be 1 upon 4 and 2 upon 8. As you can see, the denominators are not the same. Now here is an interesting point. Two fractions that are like fractions can be either equivalent or non-equivalent. And the same is true for unlike fractions as well. They can also be equivalent or non-equivalent. Let's look at some examples to see how this works. These two fractions are unlike because their denominators are different. Moreover, their values are also different, so they are non-equivalent. But look at this set of two fractions. They are also unlike because they have different denominators. However, their values are actually equal. If you multiply the numerator and denominator of 1 upon 4 by 2, you get 2 upon 8. Even though they look different, they represent the same amount. So they are equivalent fractions. Now look at this set of two fractions. The denominators for both are 4, so we know they are like fractions. However, they represent different amounts, which means they are non-equivalent. Now for our last example. In this set, the denominators are the same, so they are like fractions, but are they equivalent as well? For like fractions to be equivalent, the numerators must also be equal. So if we change this 1 over here to a 2, they would represent the exact same value and become equivalent fractions. In fact, the only way for two like fractions to be equivalent is if they are exactly the same fraction. So we have seen that two fractions can be both like and equivalent, only if their numerators and denominators are exactly the same. Now let's move on to the actual types of fractions. Take a look at this biscuit. We are going to compare two different ways we can show fractions of this biscuit. Let's draw a vertical line to separate them. On the left side, we have a fraction. Until now, we have learned that a fraction is just a part of something. It isn't the full object. Looking at the left side, that fraction fits our definition perfectly. But what about the fraction on the right? Some might argue that this isn't a fraction at all because it includes one whole biscuit plus an extra piece. Well, even though it might not look like a fraction in the proper sense, it is still considered a fraction. Why? Because even though it contains a whole biscuit, it is still less than 2 whole biscuits. It is still a broken amount. We have no doubt about the fraction on the left. It is a fraction in the most proper sense of the word. Therefore, we call fractions that are smaller than a whole object proper fractions. Fractions that are larger than one whole are called improper fractions. Let's look at this through a mathematical example. Imagine an object divided into 4 equal parts. On the left, let's take just one of those parts. This is a proper fraction because it is smaller than the whole object. In math notation, we write this as 1 upon 4. Notice that the numerator 1 is smaller than the denominator 4. Now let's take 2 of those parts. This is also a proper fraction. In our notation, the numerator 2 is still smaller than the denominator 4. What if we take 3 parts? Again, it is a proper fraction and the numerator 3 is still smaller than the denominator 4. Do you see the pattern? In proper fractions, the numerator is always smaller than the denominator. But in case of improper fractions like this, the numerator is greater than the denominator. Let's look at one more example. Even here, the numerator is larger than the denominator. This shows us the two fundamental types, proper and improper. Fractions which are smaller than one whole object are called proper fractions. In mathematical terms, we say that fractions whose numerators are smaller than their denominators are called proper fractions, whereas fractions which are greater than one whole object are called improper fractions. We can also define them in mathematical language as fractions whose numerators are greater than their denominators are called improper fractions. Look at this improper fraction. It is 6 upon 4. If you look at these pieces, you'll see that 4 of them make up one whole object because our object was divided into 4 parts. So we can write these 4 parts as the number 1 to represent that whole object. For the remaining 2 parts, we write 2 upon 4. When we put them together, we read it as 1 and 2 upon 4. When we write it this way, that is, as a mix of a whole number and a fraction, it is called a mixed fraction. So we can represent an improper fraction in 2 ways. As a straightforward improper fraction like 6 upon 4, or by writing the whole number separately and the remaining parts as a fraction like 1 and 2 upon 4. In some textbooks, you'll see 3 types of fractions listed: proper, improper, and mixed. But as you can see here, a mixed fraction is really just an improper fraction written in a different form. It's called a mixed fraction only when it's shown as a combination of a whole number and a fraction. An improper fraction is called a mixed fraction when it is written as a combination of a whole number and a fraction. Now let's go back to proper fractions and look at them one more time. Let's draw 2 vertical lines to create 2 columns, column A and column B. First, look at this circular chocolate divided into 4 equal parts. In column A, we take 1 part. In column B, we take 2 parts. Next, look at this chocolate bar divided into 5 equal parts. In column A, we take 1 part again. In column B, we take 3 parts. Finally, look at this round biscuit divided into 6 equal parts. In the first column, we take 1 part. In the second column, we take 4 parts. Now look carefully at column A. Can you guess the similarity between all those fractions? They are all exactly 1 part. If we look at it in mathematical language, these are fractions 1 upon 4, 1 upon 5, and 1 upon 6. Since all these are just 1 part of their whole, the numerator in each case is 1. These fractions in column A are called unit fractions. Thus, a unit fraction is a subtype of a proper fraction whose numerator is 1. To wrap everything up, let's look at what we have discovered today. First, we looked at the relationship between 2 or more fractions. We learned that they can be like or unlike depending on whether they share the same denominator, equivalent or non-equivalent depending on whether they represent the same total value. Remember, even unlike fractions can sometimes be equivalent. Next, we learned that there are 2 main types of fractions: proper fractions. These are smaller than a whole, where the numerator is less than the denominator. Improper fractions. These are larger than a whole, where the numerator is greater than the denominator. We also saw that improper fractions can be written as mixed fractions when we want to show the whole numbers and parts separately. Finally, we learned that unit fractions are a special subtype of proper fractions where the numerator is always 1. That's all for today. See you in the next class.